Hello, and welcome to Context Free, where we talk about programming languages. Today, as I'm recording, Christmas is coming soon, which means Ruby 2.7 is coming soon as well. I want to talk about a feature coming in Ruby 2.7 called pattern matching. It's coming experimentally, but it's still pretty exciting, so I want to talk about it. Pattern matching is sort of like a switch statement, but where you can do matching against structured data. So for example here, we have this JSON document, and here's a pattern we're going to match it against. So we notice the name Alice here, which does match this JSON object, has a children array with one member with name Bob, and an age, which is going to be stored in variable age, and whatever value it happens to have. In this case, it has value 2. So when they try to print age here, the value 2 will come out. Pattern matching has long been popular in functional programming languages such as OCaml and Haskell and others. It's also become more popular in other languages recently. For example, Rust is a relatively recent language which has a lot of functional programming language heritage in it. So here's an example from Rust where they have a point structure with fields X and Y, and they're matching it here. In lots of traditional programming languages with pattern matching, matching on data type is very common. You can also match on field values. So for example, if Y is 0, it matches here. If X is 0, it matches there. That is a match that happens in this case. Y is captured, so it gets value 7. So it says on the y-axis at 7 is what we see here. Rust. If we move on to C#, this is a little bit interesting here. C# introduced pattern matching in 8.0, and here's an example of it. And you can match on data types as you could in Rust or many other languages, but it also supports pattern matching without any particular data type being referenced. So for example here, whatever data type shape is, as long as it has property point and a subproperty y with value 100, it's going to match this pattern here, which is somewhat similar to what we saw a little bit ago in the Ruby example. Now, I want to move on to a more elaborate Ruby example so we can really get ourselves, have an opportunity to appreciate how it works. And I've chosen for this example GitHub Actions. GitHub Actions enables you to create custom software development lifecycle workflows directly in your GitHub repository. And GitHub Actions are composed of workflows and actions which are described in YAML documents. So I have some examples here that I downloaded from examples from GitHub themselves. I've got an upload artifact example. This is an action which uses a plugin called publish. Setup Ruby example, which uses an action, which is an action that uses Node to set up a Ruby environment. Or first interaction, which is going to greet new contributors and is run using a Docker image and container. Anyway, so those are examples of actions which are components of workflows. Workflows have some kind of condition on which they run, and they use actions as steps in the jobs that they're going to run based on these conditions. So this would run on a pull request or issues. They would greet the new user. Or alternatively, here's a thing to mark stale issues, a workflow to mark stale issues and pull requests that runs at midnight every day. So let's see how we might use this. I want to show an example of loading up these documents and figuring out what kind of document we have and pulling some information out from them. So we had a basic Ruby script here where I'm looping on all my YAML files and I load them up. One thing to note is I am symbolizing the names. For those who aren't familiar with Ruby, symbols are sort of like strings but have been interned and they're handled a little bit differently than strings are. And so it's important because the Ruby pattern matching works much better on symbol names at this point than with strings. So before I go into pattern matching, let's show an example of how it might look without pattern matching. I want to distinguish these workflows from these actions. I'm going to recognize actions by their runs and workflows by their conditions on which they're running. So I can say if content has key on, this is how I write a symbol in Ruby, then I can print out workflow, else if content has key runs, puts action, and just to be on the safe side, in case we read some other kind of document, let's put other in that kind of case. So if I run my program here, I want to print out the file, then print out workflow, action, or other. That's what I see here. First interaction is an action, greetings is workflow, setup Ruby is action, stale is workflow, and upload artifact is action. Okay, now what if I want to distinguish which kinds of events these are going on? Notice in one case I have an object here, or a mapping rather in YAML terminology, that has this key name, and in the other case on is a sequence. This will be mapped to a Ruby array, and this will map to a Ruby hash. So they're not the same data types at all, even though they're both a value of on. So first of all, let me get this value of on out of here. On equals content on. And to make life a little bit more succinct, because I'm going to be comparing it with succinct and, in my opinion, more readable pattern matching, I'm going to use this idiom where I do assignment inside of my if condition, but I put it in parentheses to indicate that I'm doing something unusual. And if we notice here, this Ruby style guide that is relatively popular says that this is a good idiom to use and is well established in the community. I'll make it a little more consistent and convenient, rather concise, to get this done. So now I can say, I want to get that cron description out of there. Cron equals on schedule. The first one, we're just going to be dealing with the first cron entry. It matches our case here at least. On schedule, the first one, then the value of cron. And then I should be able to say something, for example, like the cron information coming out of there. Now, if I run this, it's not going to work because I can't convert symbol into integer. What does that mean? It means I tried using the symbol schedule to access a member of this array from my other file that just had a list of events on which it would fire. So this isn't going to be good for us. However, there's something interesting. I might try to use a different kind of method. There's something called dig that came out in Ruby 2.3, which is sort of like a null-safe chaining access here, which also won't work for us, by the way. No implicit conversion of symbol into integer when using dig as well. It's null-safe, or they're nil-safe in Ruby terminology, but it is not automatically branching on whether it happens to be an array or a hash, and I still can't use schedule to get into that array. So one way to work around this is to explicitly check, do I have a hash? If on.is a hash and we have a cron, else we're going to just deal with events. Workflow schedule cron, or workflow events, which is just directly a member of the on thing. So if I run this here, I see here that I have the events, pull request, and issues, or I have my cron schedule. Okay, so this is cool. One thing I want to point out, though, is Ruby actually has other functional programming language features as well, which is nice to have. So for example, instead of saying put s on each of these statements here, I can just use the whole thing as an expression, which I really love to have that available in languages. So instead of, again, calling put s each time, I'll just store the value, whatever one it matches, into this local variable summary, and then I can print it at the bottom. And I'll put an indentation here so we can make it stand out a little bit better. Summary. Run this now. Cool. It does exactly what we want it to. Great. Now I'm going to move from this into pattern matching because personally, while I think this sort of works, it's not easy to write and it's not easy to read. Let's see what pattern matching can do for us instead. The summary equals, this is how it goes with pattern matching. I'll say case content in. I need to see if it has an on in it and capture that value in on. Or I can say, does it contain a runs in it and capture that value in runs, else something else. Okay. In the case of runs, we'll put that there. Notice my editor does not know the new Ruby pattern matching syntax, so it messes up the indentation. And I also want to check to see here if I have cron. Now this is really convenient. Watch how this can go. I have a variable called on here already without having to do some weird crazy assignment in condition. And I can say case on in schedule an array of something with cron and capture that value here. Else it'll be an events action. So I can come down here and grab these things. Again, a messed up indentation. This should have the same behavior as before, only, in my opinion, this is way more readable than this is. So let's comment this part out and see if our new version using pattern matching works. And it does indeed, only with this warning added. Pattern matching is experimental and the behavior may change in future versions of Ruby. That warning is on purpose and is important if you're concerned about writing code that will still be compatible in the future. And in our case, we're going to say, I accept that risk and ignore warnings. You can do things to ignore warnings in local areas in your code. I'm just going to be quick and just use an option on the command line here to turn off warnings. Okay, so we have the same behavior as before, but now with, in my opinion, something much more readable than what we had otherwise. Now we're also going to want to do some other things as well now that we got this far along. I'll delete the old code because we don't need it anymore. One thing that's nice is, first of all, actually what's not nice is this very repetitive nature. I want to match field on and get it into a variable called on. Same thing with cron, same thing with runs. Well, if it's just going to have the same capture name as the field name, you don't have to repeat yourself. That's the first thing that's nice in Ruby pattern matching. Second thing that's nice is when your top level is your hash, you don't need to include your curly braces. That's going to be implied, which makes it even more readable than before. I find this very straightforward to read and very straightforward to write. We run it here, we should have the same behavior as last time, and indeed we do. Okay, now before I finish my demo here, I want to do a little bit more examples of extracting data. So let's get more data from the runs here. We can see examples about how to match on values and extract values again. So we can have a plugin with its name, or using Node with a main, or else using Docker with an image. So let's do this here. Let's say case runs in plugin or in using, let's do Docker first, and we want to get the image, or in using, I'm trying to stick to double quotes, or using node 1, 2 with the main, else something else. Actually, if you don't match anything, you don't include an else, you'll get an exception currently in the way pattern matching works in Ruby. 2.7. Okay, so let's get different kinds here. Action plugin, and let's put the plugin out. Or we can say action Docker, and let's put the image out. Or action node, and let's put the main script out. If we run this over here, we should see our extra information. If we see Docker from the image Docker file, node comes from main setup ruby.js, and plugin was publish. So we got all our information out. One more thing I also want to show before I'm done with the demo though is this right here is a string, but say we just want to match anything starting with node, for example, you can use regular expressions directly here as well when matching strings, just as you could with case when switching that already existed in Ruby previously. Acts just like before. So cool. This right here has shown us how easy it is to pull out from heterogeneous structured data the information that we want. And I can imagine using this in all kinds of features. But before I finish, I also want to show a few details of other aspects of Ruby pattern matching that might be worth knowing about that I have not demoed. So if you come to this slide presentation that's linked from the release announcement, you'll see, for example, that not only can you have patterns, but you can have these guard clauses of if or unless that also need to match if the pattern matches. We also have the ability to use values. So if I just said a without the caret here, I'd have assigned the value 1 to variable a. Instead, with caret a, it means use the value from the previous variable. So it says, does 1 match 0, which wouldn't happen. We can also, if we have our custom classes, we can write a deconstruct keys method to customize how hash matching occurs. And also note that if we're matching arrays by default, it's an exact match. You have to explicitly say you want to allow other things in the array versus the default behavior for hashes is to do a subset match. There's also future considerations that they discuss here in the presentation. I'm not entirely sure which of these things have or haven't been implemented to date in Ruby 2.7, but it's worth being aware again that this is experimental and things might change in the future. In any case, pattern matching is very exciting to come to Ruby. I'm very glad for it here as well as in other languages, and I hope to see a lot more of it in the future. And I'll see y'all next time. Bye, y'all.